equity. In today's video, we're going to tackle the last section of the Art of Algebra section of SAT Mathematics. Relationships among linear equations and the lines in the coordinate plane. So, to tackle the subject, we need to first know that the systems of two linear equations in two variables can be solved by simply graphing the lines. The point of intersection, where the two lines meet, gives us the solution to the system. So, there are three possibilities when an equation in a system of two linear equations in two variables are graphed. So firstly, if the line intersects at one point, so this would be the point, this means that the system has a unique solution. And secondly, if the lines are parallel when graphed, this means that there are no solutions because there are no intersections. And lastly, if the lines are identical, meaning the two lines are the same, this means that every point on the line, so it can be here, 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 are a solution. Therefore, the system has infinitely many solutions. So the second and third case, this one and this one, can be identified when it is put into a slope-intercept form. If the lines have the same slope but have different y-intercepts, this means that they are parallel. However, if both the slope and the y-intercepts are the same, we can reasonably infer that the lines are identical. Now let's tackle some problems. 2y plus 6x equals 3. Y plus 3x equals 2. How many solutions xy does the given system of equations have? So first, in order to solve this problem, we should multiply each side of y plus 3x equals 2 by 2. So we multiply this by 2, which gives us 2y plus 6x equals 4. Then we can subtract each side of 2y plus 6x equals 3 from the corresponding sides of 2y plus 6x equals 4. This gives us 0 equals 1. Therefore, this is a false statement because 0 is not equal to 1. This means that the solution has 0 solutions. So the answer is A. However, you can also solve this by graphing it and then finding it if it has a solution. So, by graphing it, you would realize that the lines are parallel and won't meet. So this means that they would have an intersection, which means that there is no solution. Alright, let's move on to the next question. 3s minus 2t equals a. Negative 15s plus bt equals negative 7. In the systems of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of a? Alright, so as we said before, if a system of linear equations have infinitely many solutions, then the two equations must be equivalent, which means they are the same. Since the two equations are presented in the same form, we can conclude that the second equation must be equal to the first equation multiplied by a constant. Since the coefficient of s in the second equation is negative 5 times the coefficient of s in the first equation, we can multiply the first equation by negative 5 on both sides. So this will give us negative 15s plus 10t equals 5a. Negative 5a. And we can just write down the second equation as is, negative 15s plus bt equals negative 7. Now since these two equations are equivalent with the same coefficients of s, the coefficients of t and the constants on the right side must also be the same. So thus, this tells us that b must equal to 10 and negative 5a must equal to negative 7. So therefore, we have to solve this for a, which gives us a equals 7 over 5. So this is the answer to the question. Thank you so much for listening, and I hope you enjoyed our lesson, and please go on the website for more lessons and worksheets available to test your brain. Thank you.